All the source code for this lesson is available for download. See video description. You will have the source code to generate, using AI, a similar zoom-out movie to that you see below. Welcome to our guide on Introduction to Artificial Intelligence and Machine Learning. In the next few minutes, we will dive into these exciting fields and provide a foundational understanding. Artificial intelligence, or AI, refers to the simulation of human intelligence processes by machines. This includes learning, reasoning, problem-solving, and even language understanding. At its core, AI is the science of making computers do things that require human intelligence. AI can be categorized into two main types. Narrow AI is designed to carry out specific tasks, like voice recognition. On the other hand, general AI, which can perform any intellectual task a human can do, still remains a theory and science fiction. A subset of AI is machine learning, a method of data analysis that automates the building of analytical models. It is all about enabling machines to learn from data, identify patterns, and make decisions with minimal human intervention. There are mainly three types of machine learning. Supervised, where the model learns from labeled data. Unsupervised, where the model discovers patterns in the data without any labels, and reinforcement, where the model learns by interacting with its environment. As we delve deeper into the world of machine learning, we encounter a powerful tool called neural networks. A neural network is a system of algorithms loosely modeled after the human brain. It is designed to recognize patterns by interpreting sensory data through machine perception, labeling, or clustering raw input. Neural networks consist of layers of interconnected nodes, or neurons. These layers are categorized as input layers, hidden layers, and output layers. There are many types of neural networks, including feed-forward neural networks, convolutional neural networks, recurrent neural networks, and more. Each type has its own strengths and use cases. The key to a neural network's function is the activation function. This determines whether a neuron should be activated or not based on the weighted sum of its input. One of the most famous models of AI is Generative Adversarial Network, or GAN. Generative models are a type of machine learning model that can generate new data instances. They learn the true data distribution of the training set so as to generate new data points with some variations. Generative models have a wide range of applications, from generating images, music, and text, to improving cybersecurity and even drug discovery. Now that we have set the groundwork, let us dive into the core of this course: Generative Adversarial Networks, or GANs. GANs are a type of generative model introduced by Ian Goodfellow and his colleagues in 2014. They have been called the most interesting idea in the last 10 years in machine learning. In essence, a GAN is composed of two parts: a generator that creates new data instances, and a discriminator that evaluates them for authenticity. They play a continuous game of cat and mouse, pushing each other to improve. GANs have been used to generate incredibly realistic images, translate images from one domain to another, and much more. Let us break down the two main components of GANs, the generator and the discriminator. The generator's job is to create plausible data. Starting with random noise, it generates new data instances. On the other hand, the discriminator evaluates the authenticity of data instances. It takes both real data instances from the training set and fakes from the generator and distinguishes between them. The fascinating part of GANs is the competition between these two components. The generator tries to fool the discriminator, and the discriminator tries to classify the real and fake data correctly. This competition drives both to improve, resulting in generated data that are incredibly close to the original. There are many types of GANs, each with its unique characteristics and applications. We will be exploring some of these types. GANs come in many flavors, each designed to tackle different challenges or achieve specific results. Let us look at a few notable ones. Firstly, vanilla GANs. This is the original GAN structure proposed by Ian Goodfellow. It consists of a simple generator and discriminator model. Next, we have DCGANs or deep convolutional GANs. They introduced several architectural guidelines that have proven beneficial for training. Then there are CGANs or conditional GANs. They allow us to condition the generation process on specific information to generate data with certain attributes. And finally, WGANs, or Wasserstein GANs. They introduced a new way of measuring the distance between the real and generated distributions, which helps stabilize the training process. Now that we have looked at the different types of GANs, let us delve into how they are trained in the next section. Training a GAN is a delicate balancing act. It involves training two neural networks simultaneously. At the heart of this training process is the GAN loss function. This measures how well the generator is fooling the discriminator and how well the discriminator is distinguishing real data from fakes. The training process involves using a technique called backpropagation and a type of optimization algorithm, often stochastic gradient descent. The generator and the discriminator are trained alternately. However, training a GAN pair is not always smooth sailing. They can suffer from problems like mode collapse, where the generator starts to produce the same output for different inputs. But researchers have developed numerous strategies and modifications to address these challenges, enabling the creation of increasingly realistic generated data. The next step is to prepare the scripts for instructing GAN to generate the images and then to generate the zoom-out movie similar to the one you saw in this lesson. The second part of this movie is inside the next AI Deep Learning GAN lesson. See links in the description of this video.